All right. So thanks everybody for joining in. I see that we have some folks starting to log in. So appreciate you taking the time to join us in your lunch hour, my lunch hour, wherever you're sitting. Welcome to Ask Mayfield Anything. This is a webinar series that we do here at Mayfield Renewables. We have once a month that we get together with some smart folks and talk about topics that are, engaging for our industry, things that are timely typically, and trying to talk through some of the big issues that we are looking at in the solar and the solar plus storage industries. So I appreciate you joining in. As you are logging in, one of the things I do like to mention to folks is this is very much meant to be an interactive. We like to get the questions. We'd love to hear from you. And so as we're moving along, if you have a question, please use the Q&A feature of the Zoom call to put that in. If you use the Q&A, it's much easier for us to handle the questions, make sure that we get them. So use the Q&A versus the chat. And again, we'll be looking at those. We'll keep those open and be looking to answer the questions and try and do that in real time, not necessarily holding off to the very end for questions. So utilize that. We have some folks here that are happy to talk. We have some great panelists here today. And so look forward to having that engaging conversation. So real quick, for those of you who may not be familiar with Mayfield Renewables, I founded the company in 2007, and what our mission is making solar and energy storage expertise accessible. And we do that in a few different ways. One is through our engineering consulting. We do education. We do webinars. This is a series that we do. We have some code specific videos that we do. So trying to help engage with people. And then another side of the business, one that we really try and work with manufacturers, partner up with some key folks on our side, on the marketing side, and really helping bring that expertise, the product expertise to manufacturers, helping them bring their products to market. So love to talk to people about that if that's something that you are interested in doing. So yeah, so love to talk with folks and hear how we might be able to help. So before we get started in today, so we're going to be talking about software and its ability to help in the solar and solar plus storage industries. Want to just introduce our guests real quick, give them an opportunity to say hello, and just get a feel for who it is that we're talking with. And so I'm just going to go left to right here. So first off, we have Reid Gustin, the Director of Software and Sales. So excuse me, Director of Software Sales and Business Development at PowerFlex. Reid's has multiple positions, has had multiple positions in the industry. Look like you're in EV charging industries, and so been involved in EVs and stuff quite a bit. And so yeah, Reid, welcome, and yeah, kind of just give us a little bit about you and what you're doing at PowerFlex.
Well, yeah, thanks Ryan, thanks for having me, appreciate it. I've been at PowerFlex for about a year now, but as you said, in the energy space since 2018, really focused on EV charging since 2020. And in the previous few years, taking EV charging into what we're talking about today is really these multi-tech integrated systems, and how this intelligent software can kind of help co-optimize as these smart assets get deployed. So finding PowerFlex was kind of a blessing for me. In my previous roles, I really struggled to find this piece of software that had the ability to control and connect with and optimize these different assets as they're being deployed. And PowerFlex X, which is the software that we have here at PowerFlex, is the platform that was intelligently or purposely built to do that. So excited to talk to you all more about it. Thanks for having me.
Awesome. Yeah, thanks for joining. Next up, Adib Nasli, the co-founder and CEO of Zindi. So a little bit on your background. It looked like you've worked with multiple organizations, some aerospace things, and being the CEO over at Zindi, doing we'll talk more about the capabilities and kind of what Zindi is able to bring to the table. But one of the things I did want to note, saw in your bio, this is something near and dear to my heart, seeing that you teach, well, one, you're senior IEEE member, which is I think is awesome. And then also just the co-teaching of the microgrid courses at UC San Diego. It was interesting. I also saw that Zindi was doing some stuff with ASU. So yeah, I think that's great, getting that education out there, working with different entities and able to do that. So yeah, you want to give us a little bit about more on your background and kind of what you're doing with ZenD?
Sure, thanks, Ryan. Capacity building is clearly an important part of what we try to accomplish, in addition to the software side, is really the knowledge transfer and helping build the future workforce, as well as we're looking at the future of energy. So what we're doing at ZenD, we're a San Diego-based company, basically exists to take the pain out of selling, designing, and operating complex energy solutions for the C&I market. And the way we go about this is through a single platform, software platform, that delivers value at what we have identified as the 4 most critical stages, including operations for microgrids and EV fast charging infrastructure.
Great. Yeah, and so we're going to dive into that a little bit more here in a bit. So yeah, I appreciate you making the time to join us today. And then last up is Kurt Collinsworth, founder and CEO at Passage. Passage is software, designing real-world software applications, helping people bring them to life. And, Kurt, this is somewhere you've spent a lot of time. It says 25 plus years in running these UX and software design teams. So yeah, tell us a little bit more about Passage and kind of what you guys are doing in this space.
Yeah, thanks, Ryan. It's really great to be here. Great to see all the other panelists. It's a great crew of people to be on a panel with. Yeah, I've been working in software design and development for probably over 25 years now. I started Passage about 3 years ago with the goal to really specialize in software for clean technology. We also do a bit of work in medical technology as well. But I think both underserved markets for software that really considers the users. And I think as these systems get a lot more complex, we really try to help anybody that we work with to really look at the users first and see what their needs are. And that could be B2B, B2C. Software can be a tool. It can be a sticky, as we call it. We want people to stay in it, or it could be slippery. We also call it. We want them to get out as soon as possible. Both sides are things we look at, but it all goes back again to the user. I also have a lot of experience with hardware. So prior to starting Passage, I was entrepreneur in residence at Logitech, and also ran their global UX team. That's, of course, more B2C software, but some similar challenges and parallels to the industry now, where there was a ton of hardware and it needed to get connected and smarter. And so we're seeing that more on an industrial scale for all the clean tech industries that we work with. Just a lot of opportunity. We really love the space, and we're really excited to be a part of it and help in any way we can.
Awesome. Okay. I appreciate, yeah, that's great. And I appreciate you likewise taking the time and talking with us all today. So with that, we're going to jump in. We are going to launch a poll. This is something we haven't tried before, so just trying to get a little interactive, understand who the audience is a little bit better. So, so the poll should be popping up there, and we'll leave this open for a couple minutes, but just kind of get a little information on your role, and if there's specific things looking for out of this webinar. But today we are talking about software, the potential for setting up the industry advantage. And so we have different software capabilities all the way from design all the way through the use, and we'll talk about that with our panelists, and understanding kind of what those competitive advantages are, where we can go with it, and just bringing it all to life. So to kind of kick it all off, what we are seeing is, in our calls that we had our prep calls, one of the things, the theme that came up over and over again is, our energy supply is getting more complex. We have these distributed energy systems, distributed energy resources that we are putting onto the grid. And we can see here from this image that we're looking at the overall piece of the pie, where storage specifically is growing. So 2017, relatively small, and as we're seeing it and estimating into future years, we have a higher level of penetration with storage into our systems. So all of this is both creating challenges and also giving us opportunities on utilizing software for, again, both on the design all the way through the implementation and the use of our systems. And so, we are really at a point here where software is going to play a critical role. It is playing a critical role in being able to help really implement this, make sure that we are, engaging with our systems the way they're supposed to be. We're utilizing them, getting those resources to work with the way that the customers are expecting them and that they need them to do that. So first off, we're going to open it up and we're going to talk about, Passage, open it up to you, Kurt, kind of these UI, UX solutions. And, let's talk about, I think, the software, the potential for these different things. And so I guess, first off, talking about the interface and the UX as well, just kind of how does that come into play, and how is that, I guess, maybe even a little different for this industry or this, clean tech side of things?
Yeah, I mean, I think we've seen it in a couple different verticals. Like I said, I've worked at a lot of different consultancies over the years in different industries, and I think what's interesting about clean tech is that there's a lot of hardware, as I mentioned, and that hardware needs to talk to each other. Some of the people on panel, they have great software already, but software is really what enables that communication. It's really the connective tissue. And, we always, like I said, have to consider that users are the people that interact with the software to do things. And so who are those users? Are they consumers? Is this a home product? Is this an industrial product? Is this like an analytical tool? All these faces of software are different, but they all have value and they all need to be designed. I think what we've seen a lot, especially in startups that have grown, is like, the first thing you have to do is you have to have an idea for a product. And as I mentioned, a lot of those products are hardware. But then the second thing you need is usually software. A lot of times, we've seen that those are stood up by engineering teams because, you only have so many people you can hire, you only have so much budget. And so they end up getting designed by engineering, which is not a bad thing because I think, you can put that out in the market, test it, see what value it has. But I think as the industry matures and the different companies mature, like really taking a step back and again, going through like a user-centered design process, no matter what your app is, whether it's desktop, mobile, web, and really looking at like what are the needs of those users. We always like to go back to like, really talking to people quite early. We do a lot of stakeholder interviews in our process. We do a lot of user research, and we do things called personas, which like identifies who those users are. And so we really like to, again, know who those people are, talk to real users that will use the software. And then as we go through our process of building something or creating something, there's a bunch of stages to that. But and we can go back to those same users and test prototypes. We can test beta software. We can test live software. And as you know, software is never done. So we're constantly evolving it, constantly getting feedback. And, best case is like, you get a lot of that feedback early so that you can evolve the software before you get users that are unhappy. So that it's more of a virtuous cycle than a cycle where it's like you're getting bad ratings on, one of the stores where you buy apps, right? So that's again why you want to focus on users. And I just one statistic that I got from a McKinsey study about design is that companies that are design focused, and this is user experience, they get 32% more revenue than companies that don't look at design as part of one of their key practices. So there's not only value to the users, but there's also value for your company if you look at the design early. And we always say to startups that we work with, and we work from startups to big enterprise companies, like, it's never too early to look at your users and start thinking about that process, even if you don't have a lot of budget or time, because it's only going to make the software better in the long run and help it connect with your users better. Again, even for B2B, like in that software, you probably want people that are going to be able to achieve tasks and you want to get through something really quickly. We also see a lot of software where you have to have a user manual or you have to be trained on it. We always strive to design software that you can just look at and kind of use the first time that you open it up.
Yeah, and I guess that could be a difficult one, just given the technical nature of some of this. But yeah, I definitely see where that would be a goal to have for sure. I was curious on, given all of your experience, the years that you've been doing this, how are you seeing clean tech specifically, I guess, embrace this, or trying to, on that design side you're talking about, talking to the customers, getting that. Are you seeing any differences there in clean tech specifically, solar type applications, or how has that been? And I guess your experience on building that.
Yeah, I think things are getting more complicated, not less. Like, now there's energy storage, there's solar, there's wind, there's behind the meter, there's in front of the meter, there's EVs, all the things that we'll probably all talk about on the panel. And all those things, have to talk to each other to be smart. And the grid actually has to get smarter. And what will enable that on all fronts is the software, right? And I think, again, the trend is to move away from software that really is just only engineering driven to software that's going to provide value and insights, especially with all the data that's coming in. Like, the data is only good as like how you parse it or how you can look at it or the meaning that you can derive from it. And so those are all things that we consider to help, make this clean tech revolution happen. Like, I think software is really kind of the backbone of that to kind of the key at the end of the day to electrifying everything.
I was curious, and so Adib, I was going to kind of pull you into this as well. And so, being Zindi, co-founder of Zindi, just kind of curious on your experience on kind of what Kurt was talking about in terms of, developing the software, talking to the customers, understanding what it is, and kind of building that usable frame so it's, more interactive, it may be easier for the customer. I guess if you could kind of speak to your experience with that.
Yeah, so I mean, at the end of the day, we also felt that the future of energy was going to become more complex and not simpler. So as Kurt was mentioning, it's not just about solar and batteries. You got chargers, you got generators, you got fuel cells, you got different types of storage, hydrogen, thermal, and that complexity inherently demands sophisticated software. At the same time, the sophistication has to somewhat be obfuscated from the user so that they're not overwhelmed with that complexity. And what we settled on, which I'm sure Reid can speak to as well, as the most efficient approach and the most reliable approach to coming up not only with the technical plan, but also the business case, has been optimization. So there's this kind of going back and forth between methodologies, between simulation and optimization. And we feel strongly, and we built our platform around optimization as being the best methodology to deliver the benefits that Kurt touched on for end users. And we also saw some macro trends really driving the need for this, specifically like an industry standard solution. So there's this whole, I'll put them like in three buckets: market adoption and regulation, time and talent shortage, and then just a need for scalability. I mean, if you're going to do anything, you got to do it big. And when we looked at the market and really what was missing and what was needed, we saw that from a regulatory perspective, there's all sorts of policies in place to really accelerate the electrification of fleets. And then on the other side, with the folks that are running the fleets, we felt that for them to have viable strategies, they would require sophisticated on-site energy solutions. And that sophistication, I think, speaks to what Kurt and what Reid will probably be discussing together with us. And then really that usability is more nuanced in my view, which is you really, industry really has been asking for an integrated solution as a key growth driver for this talent and time shortage. And there's a lack of expertise to execute internally. And at the same time, there's new entrants. I mean, it's a very dynamic environment that then time and scaling becomes critical. And that's where enterprise grade solutions and enterprise grade software that is collaborative, that is extensible, and future-proof becomes really, really important to meet aggressive timelines, maximize revenue, and at the same time, really minimize risk, take that execution risk off the table.
Awesome. Yeah, that's very helpful. Kurt, I just wanted to I guess quickly also ask, you had mentioned B2B versus B2C, and I'm just curious on your experiences with that in terms of, I guess, one on the if their approaches, how different those approaches are, and then also just kind of the life cycle of those of that software, and just kind of how those are, I guess, a little bit different.
Yeah, I mean, I think, everybody now has great software in their pocket because everybody has a mobile phone. And all those apps have evolved quite a bit. And most of those are B2C that you would use, on a mobile device. But I think everybody's used to good user experience now. And so even though the goals may be different for B2B software, we always strive to create great software. Again, that's simple. That was mentioned earlier by Adib. That the interface doesn't have to be complex. It doesn't have to be hidden. It doesn't have to be hard to navigate, even for B2C users, because we really believe that everybody deserves to have great software. And a lot of times B2B software gets a little bit shortchanged, right? Because it just doesn't get the kind of love that B2C stuff gets. They're also more complicated, so they're harder to design. But I think if you go back to those users, you find out their needs and the goals of whatever software you're trying to create. That software can be just as good as a nice app that you might have on your phone, if not more complex.
Nice. Okay. Yeah, so I think we'll move on to the next kind of topic, kind of thing to discuss here. And so moving into, speaking of complex and bigger, more in-depth type things, modeling solutions. So Adib, Zindi is, I don't want to say it's just a modeling solution, but you can give us a little bit more info. But I mean, a big part of what this is, and we experience this here at Mayfield as part of our, the services that we do, trying to go through and model a microgrid, and what are all the potential power sources? What is the storage solutions? How does everything interact? And so, how does, I guess, kind of big question, but how does Zindi approach that? How does the software make that easier or palatable even, or something that designers can use and with some confidence?
So we look at the entire project lifecycle and where we can really deliver unit economic advantages for our customers. So at the very tip, I would say, is our Discover platform. And this essentially was developed to address a missing use need in the market around portfolio analysis of hundreds of thousands of sites. And when a majority of the EV charging infrastructure opportunities are not just at a single location, but at multiple locations, but to look at these individually and understand the solution, like, what mix of solar, battery, EV chargers, generators, whatever mix of technologies are needed, and the business case. What is the return on investment? What is the net present value of the project? What is the free cash flow that you can expect? All of these require a level of sophistication that if you were to look at them individually, you'd never get through that many sites. So Discover really is able to provide that high level portfolio view in a matter of minutes around sites. And then we also have, we felt that it's important to enable business development and sales to make selling these systems as easy as possible while still maintaining that sophistication. So, we talk about usability, and we touched a little bit on the business to consumer versus business to business experience. A lot of it is around innovation around the interface as well, to automate as much as possible so that there's not as much information input required, or thinking, I should say, required from the end user. And our proposed solution has been developed to address that by helping really the sales biz dev people respond really, really quickly with sophisticated proposals, and then come into design, which is the interface you have in front of you here. And even in design, this is a bankability level solution. you'll see the interface is very much like a video game. I would say more like SimCity, where you have icons, 3D icons that you put on top of Google Maps, and then the algorithm will generate the optimal solution for you. So again, it's optimization, and also the control strategy to orchestrate how all these things that it's recommending would come together to solve an objective that you've given it, whether give me the best economic returns, give me the best emission reduction, the best resilience, or some combination of these three. But it's really to take away that battleship gray look that at least for my previous software companies that I've owned, I was always stuck into the PC desktop. This is truly a mobile application. It runs in a modern browser, it runs on an iPad, it can even run on your phone if you want. I don't recommend it just because of the landscape on a phone, but iPad works perfectly. And it's cloud computing, it's cyber secure, but it's designed to make it fun, engaging, and help people feel comfortable exploring. Because sometimes you have to explore around some of the potential opportunities. And the other component that we feel is critical, especially when it comes to EV fast charging infrastructure and sophisticated microgrids and on-site energy systems, is understanding the underlying distribution network. So we have the concept of cables, we have the concept of transformers, and we have the concept of the loading and the power flow within these, along with the dispatch and control strategies. And that level of sophistication is what delivers not only a great outcome from a reliability of the economics and the technical design, but you can see from the interface, we've tried to still keep it very much with animation and fun-looking, inviting environment that makes it appealing to a broad audience so that we can engage and drive impact, not just at the local level, but really at the global level. And that means really, just as we talk about distributed energy, we built a system also to address distributed workforce too.
So you mentioned, and kind of piqued my interest a little bit. So you mentioned there's a couple of things here, but the transformers and the cabling, things like that. And so if you're doing something on a campus level, this looks something like I would consider as maybe a campus level type project. Yes. And you have medium voltage involved. You have probably some 480 loads, some 277, and you have 120 type loads. So that's all stuff that you're able to integrate into the software and be able to accurately depict kind of how EV charging is going to impact kind of the system at large, being the medium voltage and all of that as well.
You're spot on, Ryan. So it's about not only coming up and generating the optimal solution from like the size of the battery, the size of the solar array, the size of generators, how many EV chargers you need, or what type, level 1, level 2, level 3, but also the balance of the system. And the balance of the system can be 30% of the cost of a project. I mean, you cannot ignore cables, you cannot ignore transformers, and you cannot ignore their capacities. So if you're trying to avoid a capacity upgrade from the utility, or the utility wants to avoid that and still be able to reliably enable EV fast charging, we address that because those are inputs into the system and into the algorithm as it generates a solution. So we have the concept of voltages that you just mentioned. We also have the concept of voltage and voltage drop and kW and kVAR flows, and the system solves the operational strategy to keep it within the boundaries of the underlying infrastructure. And that same brain that is coming up with a promise in this interface that you see around the economic outcomes of the emission reduction is the same brain that then goes into real-time operation and now uses forecasting to optimize the real-time operation system. So make sure that what was promised in the plan is being reliably captured and delivered. And this whole approach from a software perspective is fundamentally to drive confidence for investors so that as they're making a decision to put money at risk, they see the sophistication in the plan and then provide a reliable way to capture the promises that the plan made. So that's been the vision and the goal towards which we have approached it from a software perspective. And this is literally running in a web browser. So whether it's a Mac or a PC or Linux, or could be any operating system, as long as you have a modern web browser, you can engage from discovery through proposals to design through operations.
Cool. And I know we're going to get into it next, but Reid, I guess I'm just a little curious on kind of your thoughts here. And this is on the modeling side, on the planning side, and Adib, I also know that, you guys can do a little bit, you can move into, beyond that. So just kind of opening up a little bit more into, without jumping too far into it, but the kind of the operations and taking this information and understanding it, and, how does that help on the operation side?
Yeah, well, I mean, it's crucial. Knowing all of this information ahead of time will help build a system less expensive and faster, right? And there's our customers, the end customers are looking for CapEx reductions and timeline reductions. Everything's taking so much longer. So yeah, having this level of granularity and visibility in the beginning, and then you, again, as Adib was just saying, using these same algorithms and strategies that you built into the initial forecast in the actual operation and optimization of the technology once it's installed and deployed is crucial for bankability. And the next piece is like the unknowns, right? When it's EV charging, well, how many cars are going to plug in? What are the driver needs? How fast do those need to be charged? And then how much available energy is there? Where's it coming from? And kind of how's that going to impact the rest of the operations?
Awesome. And so, Adib, the other thing that I was, it's on here, and you touched on it, and I'd like to explore, I guess, a little bit more, kind of the economic side of this. I think as engineers, we very often, I know that, I love seeing this, and I love getting into how's it all going to fit together? How's the power flow? How are we going to get the EV charger, integrated in and all that kind of stuff. But the economics make a huge impact, right? I mean, you were talking about the sales side of it, giving the sales folks some, ability to put this in front of customers. So I guess how do you integrate all that into it as well? I mean, is that all those inputs? Is it some knowns or some, estimates on things? And then I guess I'm just curious on, what that algorithm looks like, or what's that, are you returning what the LCOE is, the ROI, all of those things? How are you getting that information to the customers?
Sure. So Ryan, just as the technology mix can be complex and sophisticated, so can the economic inputs.
Yes.
So we do a fair amount of automation to relieve the end user from the burden of a lot of the data input. So first and foremost, the majority of the projects are grid connected. We can do islanded or grid connected with the software, but let's assume grid connected. We have an automated integration with APIs that pull the tariff in. So based on where the project is, we know the utility and we know the tariff information. And we do that through a commercial source that maintains that information. So it's a commercial source API that we go to. At the same time, there's the economics, but economics can also mean policy. So there's carbon emissions that matter too. So we use a commercial source, you give it the address, and it automatically goes and grabs the marginal carbon emissions from a commercial source at that location as well. So then when we look at potential opportunities for both cost savings and carbon reduction, we have a very sophisticated approach, but the customer doesn't really have to go and hunt for that information. It's all there. And then when it comes to really driving the economics, just as you have a lot of choices around different types of DER technologies, we enable the same from a financing perspective. So you could do cash purchase and see what the solution looks like for that. You could do a loan purchase and put in your cost of capital in. You could do energy as a service. You could do charging as a service. So all different types of business models, economic business models, are inputs into the system in a very, I would say, easy to engage with. You don't need to be an MBA to give it that level of information, just as you don't need to be a PhD to kind of design the system itself. So we put the MBA and the PhD in the same platform. You click a few buttons, do you want energy as a service, charging as a service? Do you want to buy this through a loan, cash? And even considering how the future might look, how do you envision the price of some technologies changing over time? How do you think O&M costs might change over time? How fuel prices, the tariff might change, even if there's a carbon tax that's coming in. So you can really augment your view from a business perspective into how you want this system and how you view this system growing over time. And then it gives you the business case. So the optimization, you asked what is the underlying approach. It's mixed integer linear program optimizer with a PowerFlow simulator that also automatically generates a one-line diagram with a PowerFlow study. But fundamentally, it's around getting you the best business outcomes, and it does that by giving you, the end user, the flexibility to choose different business models and looking at it from those perspectives, and then being able to make a determination. You know, is there a go or a no go on this, and getting to that no fairly quickly, and reducing those upfront soft costs by as much as possible, so that a lot of this work can be done rapidly, minimum cost, but with the sophistication and speed that the industry has been demanding.
Yeah, and I think that's one of the things that, you know, when we're going through and using the software, it's, you know, being able to get those economic answers, as we said on the planning call, you know, you can build the best, most awesome solution that's out there, but if it's not cost effective, if it doesn't meet the needs for what the client is after, then it doesn't really do anybody any good. And a big major part of that is the economic side of those.
Yeah, absolutely. And some of the metrics are like you touched on, like levelized cost of energy, and we see energy instead of electricity because we can do thermal as well. The internal rate of return, the net present value, what, for example, your minimum energy as a service charge should be, what your minimum charging as a service charge should be. So the system also gives guidance as to what you would need to look at depending on the business model you want to go forward with. But all those economics are coming together, not just based on the size of the technologies, like how big of a battery you need to buy, or how big of a solar array, or how many EV chargers you need to buy, but also how they should optimally operate. So it comes up with the optimal charging strategy, the optimal dispatch strategy for the battery or for a generator to achieve the outcome that you've given it. So it orchestrates that control strategy as well, all coming together to improve profitability, reduce carbon emissions, or deliver resiliency. And it's literally just one button you pick. You say, I want the best economics.
I was just going to say a good job on this. I think it's a great example of you know, making something that's really complex kind of actually a little bit fun and easy to use.
Yeah,
Right?
we
So
try. We try. You
I mean,
know,
it's like gamification, right? You mentioned
yeah, that's exactly it. I mean, I myself, I play video games. I always have. So, you know, if it's not interesting, no matter how cool,
yeah,
you know, how
just because it's complex doesn't mean it needs to be boring and hard to use.
exactly. Yeah, why can't it be fun? And when you make it fun, it becomes approachable. And when it's approachable, then you have a broader audience that can engage with it. And at the end of the day, if we're trying to drive impact at the global level, it has to be accessible by the masses of engineers and planners out there versus some bespoke, complicated thing that needs, you know, 9 months of training. It's just not going to fly.
Right. Well, great. So kind of, you know, continuing with that kind of our progression here, you know, looking at, you know, putting that in. So, you know, the software design, the system design, and then moving into, you know, kind of this optimization, this use of our systems. And so this is one where PowerFlex is coming in and helping support. And so, you know, Reid, will give you some time to kind of talk about that. And, you know, kind of what are the complications? What are the challenges around integrating all these DERs together, and you know, throwing EVs in there and all that kind of stuff? You know, how is it that you're approaching that, and what are some of those challenges that you guys are seeing?
Yeah, there's complexity is should be included in like every sentence. As you know, these assets have been getting more efficient. You know, they're installed and expected to be operating for 25 years, and so we know that the evolution on these properties over time is also also happening, right? So let's talk about EV charging to start with. You'll start with, you know, maybe 10 chargers because that's what you see as your need today. But as EV adoption increases across your employees or your tenants or whoever it might be, you know, 5 years down the road, you're going to need 5x, you know, 50 chargers or 100 chargers on that site. And so where your load for your facility has historically been relatively predictable or relatively flat, and we could say now you've got all of these unpredictable new loads coming in, right? When you, what's really important is this extra layer of software on top in order to guide intelligent decision making in real time based off of what's happening on the ground, right? So if and what we have in order to connect to all of these different assets, our edge controller, it provides an additional layer of reliability and redundancy, where we're not just relying on cellular networks and connecting to LTE, but we've got all of our distributed energy resources connecting to back to our on-site controller, which is where a certain set of decisions are being made based on the data that's being acquired from the assets. But then that edge controller connects up into the cloud, which is where our energy management software really lives up in the cloud, and that's where the optimization strategies are happening. That's where the forecasts is happening. We're looking at historical data, pulling in the real-time information coming from the edge, coming from the Nexus, and then every 5 minutes producing a new optimization strategy on how we can most optimally control these different assets. Some examples of the complexities and how we do this real-time decision making. So if we have a battery, for example, in on-site battery storage, your facility load peak is about 500 kW daily. And so we've got the battery set up to not allow to recognize when the facility is going beyond that set peak, and so the battery will start discharging in real time whenever it starts to see that happening. Now you'll have different conflicting strategies, right? Because at the same time on that site, you may be optimizing that battery to provide energy arbitrage and you want to pull energy from the battery from 4 p.m. to 9 p.m. instead of drawing from the grid. So that could be your base strategy. But then all of a sudden some event happens in real time where your facility's peak load is spiking. And so the optimizer, which lives in the cloud, it's part of the system. And every 5 minutes is okay, well, what is the most optimal strategy for operating these assets? Is it going to be reducing the peak, deploying the battery and reducing load right now? Or is it more advantageous to hold the battery and reduce it later from 4 p.m. to 9 p.m. because the value of that arbitrage is higher, right? So it's being able to take in, again, these real-time conditions and then use those conditions to make decisions on how to operate these assets every 5 minutes. Or when it's EV charging, every time a vehicle plugs into a new charger on one of our properties, there's a new optimization strategy that will then take into consideration what are the driver preferences, right? How much energy does that vehicle need and how long is that vehicle going to be parked for? So that we don't just give it full power from the charger as soon as it plugs in, therefore creating a big spike in load. But we're intelligently saying, okay, well, this car is parked for 9 hours. This employee is parked for 9 hours and they only need 25 kilowatt hours. So let's reduce the load or the amount of power going through the charger in real time. So that's this, real-time cloud edge kind of architecture of the system. And what is also unique about PowerFlex is that it's really a future-proof platform. So again, when we think about where the C&I market is today and where a lot of these projects are being deployed, and you showed it in the pie graphs in the very beginning. Right now, 5 or 7% of these solar projects are being co-located with solar, and in 5 years it's going to be 30%, right? And that's not even including where there's EV chargers. And so we know that these properties are evolving. We know that customers or property owners they have a sustainability strategy. They know that over the period of time, their goal is to get to net zero and they need to take all of these actions. But because of the cost of energy or because of regulatory mandates or because of whatever's happening at that site at that time, it may not all happen at once, right? So when you have PowerFlex X, you have this intelligent software that's adaptable and future-proofed, and you can add new things to it as the site evolves and goes through its clean tech journey. And then you create new optimization strategies as there's more assets deployed. It's kind of rambled, so I'll take a minute. Do you have any questions?
No, that's good. And so I'm curious on kind of these real-time decisions, and you use the car charging as an example. That one seems really interesting to me because if you're at a in an office park type setting, likelihood is that car high likelihood they're not gonna move that car all day, right? And so how are you how is it
So-
making those decisions? Or, is that something that you're saying that this bank of chargers, this is employee parking, so we know that, or it's fleet parking, so we know it's going to be there overnight, and nobody's going to move that car till, they roll in at 7:30 in the morning. I guess, how are those decisions getting made?
Yeah, there's a variety of different types of like driver personas that you could think about. A lot of the initial setup happens right after the chargers are installed and commissioned. So working with the the asset management team at PowerFlex to understand kind of what are the goals for this group of chargers. But at the end of the day, we collect information from the driver when they plug in the vehicle. On our mobile app, the driver says, okay, I'm going to be parked here till 5 p.m. and I need to get to 100%, or I need 50 miles, or I need 50 kilowatt hours. And so we take that information in real time and use it to then create different charging schedules.
Okay. Okay. And so then that requires PowerFlex to be communicating with the charger, being able to talk to it, and throttle it back if necessary.
Exactly. Yeah. So all the chargers that we connect to are, OCPP, currently on 1.6J, coming soon is OCPP 2.0 point, ongoing into future variations. There's a lot of EV charging manufacturers that say their chargers are OCPP compatible. OCPP was kind of very loosely written, and so it's interpreted and then therefore implemented differently from different OEMs. So from the software compatibility with different OEMs hardware perspective, we have a full like multi-phase testing protocol where we test in our R&D facility, in an outside testing environment, and on like several I think there's, by the time a charger gets through testing, there's probably been 1,000 charging sessions that have been successfully started and ran through on it before it gets is available to sell, because we want to make sure that these chargers are actually working, right? There's firmware updates. We need to make sure that the firmware works with our software. It's complex, and then the charger OEM will update their firmware, and so we'll have to update it on our side, right? And so there's just a lot of communication that needs to happen. And so PowerFlex we've worked with a variety of different tier 1 and tier 2 EV charging manufacturers. So an adaptive load management. So with that edge controller, adaptive load management is our patented secret sauce of our EV charging software. And that code for adaptive load management actually lives in the edge controller at the edge. So because of NEC 625.42, we're able to kind of bypass the capacity constraints of there from the utility, because the load for the charging bank is managed from our on-site controller, right? So where typically you can only put in 10 chargers or 11 chargers before the utility says you need to upgrade your service, we could put in 40 or 50 60 chargers, and then throttle back the power going to those again because of the on-site controller.
Okay, perfect. Yeah, so that's a great point, and it kind of leads me a little bit down what I was thinking about or wanted to ask about. So, we talked about doing the modeling, and so Deeb, you had talked about understanding, be able to not necessarily do upgrades, and so it seems like maybe these are two sides of the coin that need to be almost talking to each other, understanding what the modeling needs to understand what is possible from the the real-time optimization and vice versa in order to come up with this. Is there a way for, I guess the question is, how do you make that happen? How do you make sure that the inputs are getting integrated into the system as they were designed? So in that very case of, we're not going to let all 10 chargers come online at the same time, or at least not at full power. We're going to regulate that, and that has a really big impact on the modeling side.
Yeah, so it's really a multifaceted set of information that has to come in, and then the optimizer solves for that. So there has to be awareness of, which the optimizer does have, of the tariffs. So when are those time of use rates, what are those demand charges, and when do they hit? Is it coincident, non-coincident? Any real-time price signals, demand response opportunities. So a lot of the grid interaction opportunities are captured, and then the limitations of the underlying infrastructure. What is the remaining capacity within the transformer? what are the capacities within my cabling, and then all that coming together with an objective. Give me the best economics, give me the best resilience, and continuously in a continuous pattern optimizing that information. So with the plan, all the knowledge in the plan would then naturally migrate into operations because that knowledge is already captured in the plan. And now with operations, we're looking at machine learning to learn about what the load has looked like and predicting through AI what the forecasting, what the future load would look like, but now doing it at a much more granular level. So in planning, typically we're in 15-minute, 30-minute, 1-hour resolution for a number of years. But in operations, obviously that, you got to be a lot more granular than that. So it's a rolling update every 5 minutes for the next 48 hours. So instead of looking like 10 or 20 years into a plan, it's much more shorter time steps with a 2-day window of forecasting around weather, generation, loads, and making sure that EV load is being met, while at the same time being met in a way that understands the limitations of the underlying infrastructure, the opportunities from a contractual perspective with regard to grid interaction, and then maybe some nice adders. If the fleet schedule allows it, the utilization rate allows it, being able to participate in sales back to the grid, demand response, a lot of different value streams become available to charging infrastructure owner operators when they actually deploy on-site generation and storage technologies that normally would not be there if they're solely reliant on a grid connection. But to really make that happen, you need the level of sophistication that at least we feel the market has been asking for to achieve bankability around these outcomes, and then taking that same brain that made the promises into a real-time operation environment to make sure that they're actually being captured, but in a dynamic environment. So planning, we're always using historical information. Operations, it switches and it uses predictions using artificial intelligence for forecasting.
And then in comes Kurt, because now we've got these really complex multi-tech systems, and the customers are like, can I get some reporting to show?
Yeah, exactly.
How do I understand all this? Understanding all the complexity is a big opportunity. I just actually answered a question, and that was part of what I answered, is like simplifying the complexity is a huge opportunity, like just going forward for this industry. And then I think, Reid, what you had mentioned also is like consumers also at some points have to interact with this, like the app that you mentioned for the EVs. And how do we get consumers on the flip side of all this to like adopt the technology, use it, understand it, bring it to their homes and see the value? I think that's an interesting challenge in the next couple of years too, like especially V2X charging for their vehicles, like, all the different rate tiers, and like, how do we automate that? I think both your systems do a good job at taking a lot of the heavy lifting away from users and just automating it. I think we're gonna have to do that for B2C users as well.
Yeah, and that exposes a whole nother opportunity around interface innovation and obviously a different level of automation as well, given the sophistication of a CNI customer versus the sophistication of a residential customer. But definitely lots of opportunities from reporting, as Reid mentioned, through the actual interface itself.
Yeah, I would love the opportunity to show our online dashboard that customers get to go in, because I think, Kurt, you'd probably appreciate it. It's very intuitive. It's like it was built to be able to, download the report that you need within 30 seconds, within 3 clicks, finding what you need, because you never know who the end user is. Is it a sustainability person? Is it an operations person? Is it O&M, asset management? Like, who is it and what do they need? All their needs are different.
It's great.
Cool. Well, we're coming up to the top of the hour, so I did want to that question that Kurt mentioned. I want to these key takeaways I'll have up here on the screen. But Robert Cross asked a great question. Always asking the good questions here. So he mentions distributed generation, market adoption of clean technology will increase the role of software. So where does the panel see the biggest market opportunity heading into the new year? big question. I know we're running, close to the top of the hour, but I'd kind of open it up. Kurt, you already said you answered a little bit, but I don't know if you want to add to, where you see those opportunities, and we can get both Adib and Reid to weigh in too.
Yeah, I think that covers most of it. It's just the B2B side, like we just talked about. Automation's key. There's a ton of complexity. How do users get what they need quickly, get in, get out? They're doing their jobs, right? And then for consumers, just understanding. Like we did some work for an automotive company on one of their vehicles, and the V2X, like I said, like charging your house from your truck. What does that mean to users? Can you use that during peak power? Can you charge it late at night? Do you have solar? Do you have batteries? Like for the consumers, they get more complex too. I think both sides of that coin are going to be interesting to solve for.
I think I'm really excited to see how commercial battery storage evolves over the next couple of years, with prices going down, with NEM 3 and like no more NEM 2 interconnection applications very soon. Right, everything, there's just such a big push to have batteries included in like everywhere, right? Even in just everywhere. Like every new construction in California, every solar has that battery tied to it. Everything is, and there's just so many good use cases. It's exciting to see the prices going down so that people can actually start playing with the use cases and uncovering more opportunity.
And I'm really excited around the EV fleet charging opportunity. I mean, given the intensity of energy that now all of a sudden has to appear reliably and cost effectively into a single address, and a lot of these addresses, the grid wasn't designed to deliver that kind of energy at that amount.
Sure.
Which I feel is a real positive pull for these on-site energy systems that obviously include batteries and generators and fuel cells. I mean, it just opens up a whole slew of opportunities to really make that happen, and at the same time make the business case that much stronger by being able to not only reduce costs from the owner operator's perspective, but also help the grid when it needs help, so that there's managed growth from the utility perspective. They're going to see the load growth and not have the infrastructure kind of get strained to the point where it becomes problematic. And at the same time, the end user is getting the reliability, uptime from the chargers, and the speed and quality of service that they need to make their fleet operations operate the way they need it to. And that's where we see a lot of pull and opportunity around microgrids and fast chargers.
Excellent. Yeah, I think all of those, I would agree with all of those that you all mentioned. And so kind of leave that one there, but did want to get our information, our individual information. So for those of you out in the audience, if you have additional questions, comments, or anything like that, as you're looking at that, do want to, mention out again, Mayfield Renewables, we are, working with manufacturers quite a bit, doing product market fit services in conjunction with our partner, Crest Creative. And so being able to, do those, be able to help bring those products to market, kind of all these things that we've been talking about, helping end users, helping the business customers, definitely something that we enjoy doing and would love to talk to people about. And then a couple other things as we're wrapping up here. I'm super excited about this. Mentioned education at the top of the webinar. Mayfield Renewables, we've put together some of our own courses. We have some stuff that's available on our own website. So I'm really excited about these. Have some longer form courses on solar plus storage, both NFPA fire codes and also with the National Electrical Code. And then also most recently with a UL 3741 system. And then the other thing I meant to mention it with the last slide, but Intersolar 2024 is coming right up. We will be there. I'm presuming the panelists will be there, or some form of companies there. And, always excited to talk to people. Our partner who we're working with, Crest Creative, is helping put together Clean Tech San Diego event. And so the day before Intersolar, we're going to be talking to some clean tech folks. If that's of interest to people, would love to get you that information and see people at that event. And then
I'll see you
finally,
there, Ryan, I'll be there.
you'll be there. Great.
Yeah.
Kurt will be there. I'm presuming Zendi and PowerFlex on some levels will probably be there, or representatives from the companies.
Yes, looking forward to it.
Yeah. Sunny San Diego, January. It's got to be, it's a perfect place to be.
Everyone should
then-
come and defrost.
That's right. And then finally, next month, we are going to be talking about design considerations for energy storage systems. So, adding on to some of the stuff that we were talking about in that modeling and all those things. So I hope folks are able to join us there. So with that, I want to say thank you again to our guests, Reid, Adim, and Kurt. Thanks for taking the time. I really appreciate you spending the hour with us, giving us some insights, and I really appreciate everybody for tuning in.
Yeah, thank you, Ryan.
everyone.
Thank you,
Appreciate
everyone.
it. Thank you.
Great.
Bye.
Thanks, everyone. Have a great day.
Bye-bye.